Chapter 17 Test of Significance. In this video, I am going to discuss this example. A health researcher read that a 200-pound male can burn an average of 546 calories per hour playing tennis. 36 males were randomly selected and tested. The mean of the number of calories burned per hour was 544.8. If the population variance of burned calories is known to be 9, at alpha equal 0.01, test the claim that the average number of calories burned is actually less than 546. First, let me write the given informations. 36 males. Therefore, the sample size is 36. Then talk about the mean of the sample. The mean of the number of calories burned per hour was 544.8. Therefore, that is the sample mean. So X bar is 544.8. Then population variance is given, which is sigma squared. Sigma squared is 9, but we need sigma, which is population standard deviation. Therefore, we get the square root of 9, which is 3. Then alpha. Alpha is the significance level, that is 0.01. Now we do have all given information, and then go to the step 1. What is the step 1? Null and alternative hypothesis. First, we have to identify the alternative hypothesis. What is the alternative hypothesis here? Go with the last sentence. They claim that the average number of calories burned is actually less than 546. So we need to check the less than part. Therefore, the alternative hypothesis is mu less than 546. Then null hypothesis mu equal 546. We use always equal sign under H naught. Once we identify the null and alternative hypothesis, we can go to the step 2. What is the step 2? Test statistics. Before you decide the test statistic, check for the sigma. Sigma is the population standard deviation. If population standard deviation is given, we can use the test statistic Z naught. If it is not given, we cannot use the test statistics Z naught. Here sigma is given, so we can use the Z naught. Z naught equal x bar minus mu naught sigma over root 10. So x bar is the sample mean, which is 544.8. Then mu naught is the value under H naught, which is 546. Then sigma is 3 and divided by root n, root 36. Then it is negative 2.4. Then we know the test statistic. Here negative 2.4. Now we can go to the step 3. What is the step 3? Find the p-value. Before you find the p-value, you have to check the alternative hypothesis. Why? P-value depends on the alternative hypothesis. As I explained in a previous video, first check the alternative hypothesis. Right. So what is the alternative hypothesis here? It is mu less than 546. So this is left tail test. Then how do we check the p-value? Yes, if it is a left tail test, we know the p-value is the area under the curve and the left to the Z naught. Z naught is the test statistic. So here we know the Z naught. So we need to find the probability Z less than or equal Z naught for the p-value. So our Z naught is negative 2.4. Then we need to find the probability Z less than or equal negative 2.4 for the p-value. Since this is less than or equal, you can use Z table directly. So the probability of Z less than or equal negative 2.4 is the 0.0082. Therefore, p-value is 0.0082. Once we have p-value, go to the step 4. Step 4 is the decision and conclusion. Then how do we get the decision? We reject H0 if p-value less than or equal alpha. Therefore, we need to compare our p-value with alpha. Our p-value is 0.0082 and alpha is 0.02. Therefore, p-value here less than alpha. Then decision is we reject H0. Then how do we get the conclusion? To get the conclusion, think about the again null and alternative hypothesis. Here null hypothesis is mu equal 546 and alternative is mu less than 546. So decision is we reject H0. If we reject H0, that means we don't agree with H0. There are two options. Therefore, we have to go with the other one, which is HA, alternative hypothesis. Then alternative hypothesis here, mu less than 546. Therefore, we have to agree with it. So we can now give the conclusion there is enough evidence to support the claim that the average number of calories burned per hour is less than 546.